Good morning, everybody. John's given me an introduction there. The title is Getting It Together, which was really looking at the idea of the integration, but to really look at a story of the Port of London and our development with multi-beam. I might have to stop this because I think it might have started automatically with time-ins, but the objectives are: I'll give you an overview of the Port of London and the hydrographic service. Specifically the RESON systems, what we have, how we've used them, and for those of you who were up late last night, I'll do lots of pretty images, not so much on the text today. It should help you all. I'm really focusing in on the use of the high resolution multi-beams that we have for marine structure inspection. Some test results that really are just out last week. As I'll mention in a minute or two, we do deliver a Cat A course with UCL, and some of the projects this year, one of them was a RESON sponsored project, and we've looked at some landmark laser and vessel-based laser systems, and I'm going to show you some of those if I have time. If everything works and the whole thing doesn't collapse, I'll give you some examples of free viewers that we use and just some conclusions. So really we have to put this slide in because I'm here representing the Port of London, but we're a self-funding organisation, receive no funds from the government at all, about 340 staff. And the primary role we have is safety of navigation. That's critical. That's why we have the multi-beam systems. The vessels that we're looking at here, they come into the Thames with about 0.9 of a metre under their keel clearance, with a tide maybe falling 1.5 to 2 centimetres a minute in some cases. So it's all pretty critical stuff. So accurate multi-beam, the driver for what we've done with the pretty picture type stuff, is very much based on that safety of navigation. We're about 70 terminals, we're the second busiest port in the UK, and quite a large area, 95 miles in length and 400 square miles. We're lucky in this sort of recessionary times, which is affecting the income to the port in some ways, but we have a lot of major projects going on, over £35 billion worth. The Olympics was on there, and that finished this year successfully. We had some involvement in that, but lots going on. And I'm going to show you some examples of work that's associated with some of those projects as well. That's our area of operations, really, from the west of London here, where you can walk across the river. It's about 70 metres wide, 80 metres wide, really out to the southern North Sea here, which isn't a lot far off. When I was working offshore many years ago with Raycal, etc., we get similar conditions right out there sometimes than we used to have in the North Sea. So we need an array of equipment. The hydrographic department, we've got 3 survey vessels, and much to the pleasure of RESON, they're all fitted with RESON systems and the Planix POS NVs. We've got 15 staff, the size of a small little company, I suppose. 7 surveyors, including myself and John Pinder, who's the port hydrographer. 5 field staff, we have an oceanographer, GIS and tidal managers. So we manage all the tide information for the Port of London as well. And we also manage and maintain 7 gauges belonging to the Environment Agency because of the flood defence network on the Thames. We do about 400 surveys a year. 40% of that is work on contract, and excuse me, although entering into the world of commerce can be a challenge, it brings in money, which is why we do it, and the board like that, but it does sort of give a bit of rigour to your work, and if you've got specifications and timelines to meet, it helps us a lot and gets us working with other companies. We work a lot with Net Survey, we interact with RESON and other companies as well that help us really improve what we do. I think we have gained a national and maybe even an international recognition in the development of multi-beam for high resolution surveying, and I'll show you some examples of those. And very importantly, I think Danny alluded to it yesterday, and we've just had Doctor speaking to us about the Cat B course. You really do need trained surveyors to get the most out of this equipment. Effort in equals results out very much. And since 1999, we've been conjointly delivering a Cat A course with UCL. And the numbers have stabilised. We had 14 last year, 16 started, 14 finished. We had 11 show up the week before last from this year, and from all over the world. We've got someone from Finland, Singapore, Malaysia, Hong Kong. We've got a French student there this year, 3 or 4 English people, an Irish person, and so it's good. And all of those people went into work in the industry last year that wanted it, so it's a valid thing. So our equipment. We've got 3 multi-beam systems, as I say, and they're really, if we look at them, the first system we got in 2004 was the 8101, really for dredging support, safety and navigation surveys in the channel. And we upgraded that to the 7101 in 2010. The Antlet, I'll show you some images of the craft afterwards. We've got the 8125 in 2005, very much on a business case, the high-res, looking at wreck surveys, particularly because the MCA the Marine Coast Guard Agency had started to use multi-beam for wreck surveys and potentially not sweeping the wrecks. And we've over 500 wrecks in the Thames. And we had a major port development going on and had to look at the critical depths over the top of those very closely. We upgraded to the 8125H in 2011, which again has been successful, works well. And then our most recent system was the 7125. It was the second variation of that was out. And we upgraded to the 7125 SV2 this year. And actually that's just been fitted this week. So I'll be going on the boat maybe this afternoon, and we'll start to sort of play around and look at the functionality we're going to gain from that. So we've got all the systems, so there's no sales prospects there for you, John, at the moment. But maybe not. We're thinking of building a new craft in 2014. We're looking at that at the moment. And you never know, we might go dual head or something like that, but we might look at the way we do our operations and see where we are. All our vessels have Planix POS MVs, which we're fortunate to be able to put onto those craft. And I think, as Peter said, they are the best performing position and IMU systems out there. Processing is high pack, high sweep into Fledermaus. They're the survey craft. Really sort of small, medium and large type idea. When you looked at the map we have, or the chart, the overview I said of the port, the verifier is a 21 metre target towing vessel for the Navy and a fishery protection vessel, etc. Had a few lives, but she survived being a target towing vessel, and she works for us now at the 8101 on. Permanent fixed hull mounts where we can put them, and that really has paid dividends. I think we've got very good data. Both of those craft, the 2 permanent fits, we'll be getting data received when we're doing 16 or 17 knots. So we surveyed about 11 knots, between 9 and 11 knots on those craft, so good survey speed. And then the Galloper, smaller, we've got a moon pool on her for fitting her, and she goes on a trailer and goes off and does work in other ports, and very shallow draft for us. And we just deploy the multi-beam, which you can see here, on a moon pool. So we travel to site at 20-25 knots, so we can deploy that then. We survey speed with her is about 6 to 7 knots for the best sort of survey results. So some of the talks yesterday as well were alluding to the fact that with multi-beam, the main reason we got it for, our primary reason, is producing charts for our harbour masters, pilots, berth owners and visiting mariners. All the data on the UK hydrographic, the chart series for the Port of London, of which is 11 charts, is all Port of London data. But really, having this information starts to open up new customers, new people who want that data internally in the port, and from environmentalists, geologists, archaeologists, even down to security and port security, etc. But critically, where we've developed, if you want to say, our contract side of things is with engineers, hydrodynamic and civil engineers. Some marine side, but a lot of them land side, who aren't really, it's a very new adoption for them. And that's a real driver for this integrated solutions. So in the early years, if we look at when we started to use our 8101 and 8125, we've got our standard Batty chart of a berth. It's in plan there. So it shows you, but the idea that the clarity of the output we were getting, we'll see the same resolution on that screen, but in the image we see, you know, this is the same chart. There's a large spillage of material off a conveyor, off an load in here. It really does help with the clarity of output, and I think it's sort of, one of the things I'd say is everyone thought we were absolutely fantastic technical genius work, when you started to show them a picture, people do like a picture. And Danny said yesterday that imagery can be quite subjective, and it's right. Imagery shows that you've got good results. It can also be a way of hiding iffy results. But it really does help, and hope to end up with the free viewers at the end of this, because I think it's a huge value add to multi-beam. I say since 2004, I've been at the port for 16 years on. It's really like moving from radio to high definition television, if you want to say. That's what, we sort of haven't got a lot of surprises on what's on the seabed, but we know so much more about how it's changing. Critically for our day-to-day work is that simple idea of just a different surface. This is a difference of an area of about 2 kilometers of the river, surveyed in about an hour and a half, 2 hours. And there's been some dredging here, water injection dredging, so the blue are areas that have got deeper, the red and yellow are areas that have got shallower. And really just by producing, this is a sand wave area that's just moving up and down probably twice on a tide. So the critical depth over the top of these sand waves hasn't changed that much. But, you know, again, we could write a long report, we could go and see everybody, but you send someone an image and say, you've put 1.5 meters of material too close to the channel edge, which is this black area here, please go and remove it. It really does help. So we use every single survey we do on the Thames now, we produce a difference model between the previous survey, because we do a lot of routine resurveys. The accuracies, again, early days of our systems, we started to look and we were quite happy with the sort of level of accuracy we're getting. That's a scaffold pole in 9 meters of water. So to be able to detect that, potentially identify it, because critically in the Thames as well, you cannot see your hand in the water. Not so much that it's dirty, but it's very high sedimentation rate. So a diver cannot see his hand. He can hardly see his own bubbles sometimes. So to be able to give more information is sort of operational critical, and really allows to pre-qualify targets for diver inspection or to clear an area safe after some works. But the 2 colours there show really we've got 2 independent passes, and that was leading us to look at the reliability, the repeatability we're getting for the data. Really 2 or 3 centimeters different between the vertical and horizontal position at 2 independent sweeps on this target. Very good performance, really. And again, when we were doing our standard berth surveys, we'd be looking at the depths alongside for the vessels to moor here, or pre or post dredge surveys. We started to pick up the areas that would be common to any of you who use multi-beam now, but in the early days to us was a sort of enlightening in a way of what we could do. We started to get some feeling of what the structure was. We were able to look beneath structures. We were critically able to survey a berth in maybe 10, 15, 20 minutes, whereas it would have had to take 20 or 30 lines with single beam at 3 meters. So we started to look at sort of value added and other things we could do with the data. That's a sill to a lock where there's some collapse here and change, and we'll get back to that later on with one of the free viewing demos. But again, that sweep was actually taken during the site acceptance test for our 8125. Just 1 sweep in and 1 sweep out. And at the time it was, when John and I think Richard Hill was processing that, we looked at that and said, the asset managers of this area here might have a bit of an issue that they have to look at. So really then we started to look at using this technology and use we had on all our survey boats, so we had 2 systems at that stage, for doing stuff outside the common day-to-day safety and navigation surveys. It really is tangible results, good project support, and critically now in the area of health and safety is if you don't have to put a diver in the water, you don't, and you use your dive time to go and inspect what you've found, if you can, by remote sensing or remote inspection. We have done some, that's a turbine for a wind farm. There's 3 major wind farm developments in the Thames, which is on our doorstep. But more recently, we've done repeat surveys for Dong Energy, the Danish oil and natural gas company, and clearly they have 10 diver tasks that have to be done to inspect a turbine, including checking the seals where these J-tubes go in. This is the cable coming in on the bed. The amount of growth, the angle where you have the support that the cable is supported, where it comes under where it enters into the J-tube, depth of scour, etc. And what they found, by working with them, we've looked and said that by using the multi-beam and getting the high res, we can probably deliver 6 of those for them. And that's critical because a dive support vessel might be costing somewhere between 40,000 or 30,000 pounds a day and 60,000 pounds a day potentially. So to be able to take 60% of their work away and then let them get on with doing more productive diver work is really beneficial. Excuse me. One of the areas in central London is in Blackfriars. I should have had an aerial photograph here. I don't think I do, but we've surveyed that 16 times over the past 4 or 5 years for the Environment Agency and for Balfour Beatty, or the rail company, because they're building a railroad over the centre, in the centre of London. So it formed a very, very strong data set for us to analyse on the repeatability of the system. I'll try and play the mouse here and see if it comes up. But we started looking at that as a really good example, which I'll come on to next, of looking at the absolute repeatability. So over a period of, say, 3 years, if we took out of that the amount of data sets we had, and really starting to, we think we have very good data, but it came up yesterday as well, a lot of the questions. It's sometimes hard as a hydrographer to verify the absolute accuracy of your system. You can statistically get it, unless you've got somewhere you can go and visit and survey and do that. So I'll get on to that. But this is one of the scenes, the way we deliver our data to clients. We've got the full area with the Fledermaus, which, but you've got your X, Y, and Z depth down here. I mentioned about the difference models that we produce. So there's a difference model between 2 surveys. This is all the way back in 2007, 2008. And again, given to your client, he could run his cursor along, and you'll see that we've got the differences of a centimetre showing there. So between an interface of 3 months, that area, that particular spot, we're saying, has only changed by a centimetre. We've got sand wave fields developing here. We've got a berth where there's fast ferries coming in there with water jets that are churning up and scouring out the bed. So we've got an erosion in there of something in the region of half a metre of material, which might be significant. And the vessels that are transiting the bridge here in central London, they might only have 20 or 30 centimetres under their hull. So a change of 60 centimetres is critical to keeping them able to carry their passengers. There's over 110 tourist passenger carrying craft plying up and down the centre of London, where we're looking at here. And at the time we were doing this, this was done at the start of the works. The developer and the engineers had very little data as to the structures itself and the bridges. They're building a new railway bridge across here. It's nearly completed now, at this stage. So I want to look up and maybe be a bit disappointed with what you can see on that larger screen. But we started to look at it, and we were able to see, that's not too bad, we're able to see these were drainage holes from the centre of the bricks in the bridge pier, which were of interest to them. We could see the original wooden piles of the original bridge and structures here. Those all helped them, and we could monitor scour across the area. So we're baselined the whole area for them. You see there's some scour in here, so that interaction area down by the base of the pier, which is one of the reasons we purchased the 8125 originally. Let's shut that down. So I was talking about repeatability and accuracy. We use this area. One of the deliverables we have to do of 28 separate deliverables for the Environment Agency that have to be produced out of this survey is really looking at the repeatability. And they asked us to extract point data from the 100% multi-beam coverage. So the indications were, where we believe this area is relatively stable, was maybe 2, 3, 4 to 5 centimetres repeatability. So this year, one of the UCL projects, we looked at really identifying an area. It's a 7-meter tide range there. So we picked an obstruction, this area. It's an old entrance shaft. There used to be a power station on site, relatively stable. Nick, one of the students, we did a full GNSS control survey, total station, repeated measurements on this enclosure, so highly accurate survey in the region of 2 millimeters to 4 millimeters misclosure. So we had a really good target. We've surveyed this 16 or so times, and we picked 3 data sets. This survey from 2010, a little bit sparser. Survey in 2011 with the 7125, huge amount of data. Surveyor obviously had lots of time on site and got some good data. So we're looking, these are the point cloud, each individual point of the processed multi-beam data. So we have a 3-year spread. And we started to try and pick off these inner, or Nick picked off these inner corners. And then, so we've got 2 data sets. And we're really happy. We only corrected this last week, really. There was an issue with the 2010 horizontal RMSE of 20 centimeters, but again, we use POSPAC. There's bridges there. We transit beneath bridges, etc. And we have days that again, that was earlier in our processing knowledge, etc. But when we look at here, really, we're getting down to 2011. That dense data set, we're getting 3.5 centimeters, 35 millimeters, independent between the multi-beam, which is the whole multi-beam system. It's the multi-beam, the planics, tides we were using there. We weren't using GNSS vertical, so we're very happy. That's a nice specification to now be able to put in to show to prospective customers. So very good. With the repeatability, the RMSE, we're looking there in the vertical, really looking at the mean of about 4 centimeters, 5 centimeters, which again is quite pleasing, because if we look at your TPE values, you're looking at potentially we might have a 5 centimeter inaccuracy in just the tide alone. So really happy with those sort of results.